this video, we're going to have a look at factorizing simple quadratics. A monic quadratic expression is an expression of the form ax squared plus bx plus c, where a equals 1. Since 1 times x squared is x squared, monic quadratic expressions can be written in the form x squared plus bx plus c. Expanding binomial products can result in monic quadratic expressions. For example, x plus 2 times x plus 3. Let's expand, taking the first term from the first brackets, multiplying it by the second bracket, plus taking the second term in the first bracket and multiplying it by the second bracket. Expanding it out, x times x, x squared, x times 3, 3x, 2 times x is 2x, and 2 times 3 is 6. Our middle two terms are like terms, so they can be combined. Therefore, we get x squared plus 5x, because 3x plus 2x is 5x, plus 6, which is a monic quadratic expression. We can also use the area model to help us expand. We have x and 3, x and 2. The area of the first, length times width, x squared, 3 times x, 3x, x times 2, 2x, and 3 times 2, 6. And our like terms that are on the diagonal can be combined to give us x squared plus 5x plus 6. This process was called expanding. The reverse process is called factorizing. So factorizing is the reverse process of expanding. Here we're asked to factorize x squared plus 7x plus 12. Now we know, because it's a monic quadratic expression, that the first term in both brackets must be x, because x times x is x squared. And we know that the constant terms must multiply to give us 12. So we're a bit unsure what goes here. And the sum of these must equal 7x, our middle term. So let's think about this. Taking our constant 12, to get it as a product, we can have 1 times 12. Now, if it was plus 1 and plus 12 here, we'd end up with 13x, the sum, 1 plus 12, 13. And we're after 7, so it didn't work. We can also get 12 by 2 times 6, getting our product. If it was 2 and 6 here, we'd get 2x and 6x, which would add to give 8x, which is not what we're after. We're after 7x. So let's try finally 3 times 4, giving the product of 12. So we want our products to be 12, and we want the sum to be 7, being the coefficient of x. And here we have, yes, 3 plus 4 is 7. So if we put 3 and 4, it doesn't matter which way around, we have 4 times x is 4x, x times 3 is 3x. They would combine to give the middle term 7x. So now we know our two numbers, plus 3 and plus 4. And to check, we could expand. Let's have a go at another one. X squared minus 7x plus 10. Now, let's think about this. Our middle term, or the coefficient of x, is negative, so that our numbers have to add to give a negative value, but then they have to multiply to give a positive value. Now, a negative times a negative is a positive, so we know that the two numbers we're looking for are negative, and the product is 10. So we can have negative 1 times negative 10. Now, if we added those, we would get negative 11. It's not what we're looking for. We're looking for negative 7. So now let's try negative 2 times negative 5. They have a product of 10, and yes, they sum to negative 7. Therefore, when we factorize, here's our two special numbers, x minus 2 and x minus 5. And again, you can expand to check. Lastly, factorize x squared minus 64. Now this looks very different to our other monic quadratic expressions. Recall that this is a difference of 2 squares. That is x squared minus 8 squared. Taking the square root of 64, we get 8, and difference being subtraction. Therefore, x squared minus 64 will be x plus 8 and x minus 8. And that's the special one to look out for, the difference of 2 squares. And there you have it, very simple factorizing simple quadratics when either we've got a difference of 2 squares or a equals 1.